Live. Hello, 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 everyone listening to us on the Virtual Jack podcast, and greetings to everyone who is watching on YouTube. Really happy that you found your way here. Today there is no Simon to play the role of Virtual Jack, so everything is in my hands. I'm a bit nervous, but I'm super excited to welcome John Davies at this Rebel Labs interview with a Virtual Jack speaker. And welcome, David. John is an entrepreneur, father, a CTO, and the co-founder of C24, which is a fast data company that helps enterprises rapidly adopt messaging standards and optimize in-memory computing solutions. He's also a photographer, a geek, a traveler, and you can find him and chat with him on Twitter. He goes by @JT_Davies. He's really friendly, so don't be shy. Hi, John. Really happy to see you. How was your session today? Was everything up to your expectations?
Well, from my point of view, you sort of turn things on and you hope all the screen shares and bits are going to work, the resolutions. I mean, that's really the only sort of bits that could go wrong, I think. So, yeah, so for me, it went well, and you guys were watching, and so from my point of view, that was good, and some good questions at the end as well.
Yeah, from our point of view, everything was fine. Hopefully you didn't have a hard time talking without actual audience, but well, you managed to give an excellent session. So during those interviews, you usually start with blitz questions for the speaker. Those are mostly yes or no, or just a single choice questions. So you don't have to explain yourself. You can tell whatever comes to your mind first, and you won't be judged based on your answers. So is computer science a real science?
Yes.
That's good. Do you like static or dynamic typing more?
Oh, static.
Great. What is your favorite JVM language?
Java. Have to be Java.
Before 8 or Java 8 and higher?
Oh, Java. If we're going to go down that route, then definitely Java 8. Yep, absolutely.
Yeah,
it's almost a different language. So.
Well, Java is not surprisingly one of the most favorite answers to this. What is your favorite open source project?
That's a good question. I can tell you my least favorite is probably Maven.
That's a good one.
Good. I win on that one's okay, is it?
Okay. So, and then a bit deeper, maybe, what is the worst thing that a programmer can do? What is really a terrible habit to have as a software developer?
I think not understanding what they're doing. I mean, it might sound sort of a very easy thing to say, but actually not understanding the environment they're working in. It's what I'd call drag and drop programmers that aren't, should we say, real programmers.
Okay, and that nicely takes us to longer questions. So you gave a session about performance of Java code and how to use certain approaches to make programs run faster. And obviously, you are a very established performance consultant in Java world. So what do you think are the best tools for a performance engineer that they have to master like 100% to be comfortable doing performance work, to understand the environment and things like that?
To be honest, I come from I suppose the old school where I like command lines. I use Emacs. I use grep, Unix tools, etc. If you're really going to go down into performance, really the only thing you'll get sort of some real details out of are the sort of the Unix commands, iostat, etc. Rather than there are many Java tools, the JVisual VM, etc. are okay, but a lot of the tools lie to you. They don't really tell you. It's not that they're wanting to sort of lead you astray, but connecting to a machine which is running right on the limit just doesn't happen. It doesn't work. The only way you're going to find out what's going wrong or what's happening is command line tools. And many tools you can build yourself, even as far as writing system.out.println is quite, you can solve a lot of things with that. I suppose if I had to choose a tool, I use a tool from the JClarity guys called Sensum, which is a JVM analyzer, which I find very good. Oh, it's a garbage collection dump analyzer.
Yeah, they have a couple of products
Yes, that's right.
working towards performance work, and definitely if anyone who's listening into those sorts of things,
I mean, ultimate tool. I mean, my favorite. It boots up almost every time I fire up my machine is IntelliJ.
well, yeah, that's where you write your code. That's where you can run experiments and so forth.
Absolutely.
Well, coming from that, and you said that you were more like old school, maybe developer. So, and before ages before now, so there was all the programs were single-threaded, right? Mostly.
Yep.
So, how do you think the performance of a single-threaded program and like performance work and how much attention should we pay to that is different from optimizing the performance of a multi-threaded program? Because we essentially want to scale systems, right? That means usually we want to go horizontally as well as vertically. And I would assume that there is a different skill set at work. Do you think one is more valuable than the other, or what's your point on that?
Well, ultimately, you have a few choices here, and I think to answer your question very briefly, there's a massive divide between single-threaded and multi-threaded. So, but you have a bunch of choices. You can write something single-threaded, which is thread-safe, and you can use another tool to effectively make it multi-threaded. You can write a Lambda, and you can use a parallel stream. All of a sudden, it's multi-threaded. You can put it into an application server. Again, it's sort of almost instantly multi-threaded. You can put it into multiple VMs, you can put it into multiple microservices or virtual machines, and again, you're making best use of your machines. I think for a programmer, multi-threading or debugging multi-threaded code is very complex. I think you have to know about it. It's every machine we get these days is, I mean, even little tiny things like Raspberry Pis and the phones we have in our pockets are multi-core, and therefore, if you don't write multi-threaded code, you're not making best use of the machine and the hardware that you've got. Akka is another. There are lots of sort of different frameworks and things which, again, provide the multi-threadedness, but it's something which is very complex, but it's something which I think everyone should understand and know about. And,
do you think you can
distributed as well? I think is extremely important. If you come out of the bounds of your single machine or your single virtual machine, you've got to go distributed. Again, to be scalable, you're not horizontally scalable if you're forgetting the tooling. Single-threaded or even multi-threaded, you have to decouple your applications and you have to make them distributed. Otherwise, you're not scalable.
So this touches onto the hyped subject of microservices a little bit. Do you want to voice your position that are we running ahead of time? Because currently as an industry, this is a really well discussed topic. Microservices, containerization of everything, trying to isolate small things. But at the same time, this comes against some maybe performance rules that you want to keep things local, right? And not to use like complex interfaces. You don't want to pack layers of abstractions. Do you think we will need to relearn very many aspects and rules about performance that we have learned so far with the microservices coming?
Yeah, whether it's coming or not, I don't know. You've got so many different layers of virtualization these days. I'm certainly, I've used and I'm a fan of Docker. It's not something I use every day, but I've messed around with it quite a bit. We deploy some of our things on Docker. We have clients that use Docker. Cloud Foundry absolutely has its place, and we've got a lot of clients using Cloud Foundry. They both address different aspects of the microservices sort of problem area, shall we say. I have this belief, though, that a lot of the Docker, for example. You imagine a PHP programmer or somebody who works on a database or SQL. They can't deploy their code without dependency on everything else. You look at a LAMP stack, you need all the other bits. You need a web server, you need a database, you need the PHP or Python or whatever it may be. So to deploy something, they have to use a microservice to package all of these other things together. Otherwise, their program doesn't work. We're very lucky in the Java world because we can do everything. We have almost access to the entire sort of menu of things on a machine. We can set up a web server. You can use Tomcat or Jetty or Vertex or whatever you want to set up, or even just write a couple of lines of code. You can create a database. There's no end of databases. You've got all the mapping layers. Everything you need is in Java. And so really, when we create a service and we want to deploy the service, we're using Spring Boot to the deployment of the service. And in many cases, we don't need a microservice. It doesn't mean that they're not that they're dysfunctional. Certainly, if you get into large-scale productions, then something like Cloud Foundry becomes almost a must.
Yeah, that's true. That simplifies work of the operations team so much. So it's time to start wrapping up. And since, well, I've noticed that performance is one of the aspects, like this is but not a buzzword. I don't want to call it a buzzword, but this is something that attracts almost universally attention of almost any Java developer. So, and obviously not that many people understand that well. So could you recommend any resources or books, or maybe, I don't know, any resources, how to learn things about Java performance? For maybe targeting maybe a junior developer. Let's not go into like very sophisticated resources where you cannot beat the experience, but for a junior developer, definitely you should be able to recommend something. Can you?
I'm hopeless at remembering names and things, so I couldn't quote specific books or names. There's a classic book on concurrency in Java. But that doesn't necessarily make anything go faster just because you're using more cores. Again, there are so many aspects about multi-threaded and concurrency that you can give it any number of cores, it just won't go any faster. So I think, how could I? It's really the machine that's sitting in your average laptop is so unbelievably powerful. I think what you should do is a little bit like in the session I've just given. It's take a date. It's 48 bytes in Java. You only need 2 bytes. You now have a goal. Optimize down. Find a way of getting down to those 2 bytes. Look at the number of instructions your processor will run. Look at what you're trying to do. Work out how many you theoretically should be able to do, and don't settle for the fact that things are slow. We're quite happy with processing 1,000 messages a second on a machine, but when you realize this machine is processing 4 billion a second, there's something wrong, and that's per call. So I think people take too much for granted what the machines are capable of doing today. So advice for someone else is really do the raw maths, work out what it is, set yourself a goal, and just keep working at it, because it will just get faster and faster. By orders of magnitude, 20% is nothing. You should be doing that every hour. There's a long way to go.
That's great advice. As they say, aim for the moon. Even if you miss, you'll be amongst stars. So yeah, maybe. Well, as long as you can breathe in space. It's a motivational quote. So yeah, nothing beats experience, and time showed that times and times again. So at this point, thank you. I'm out of questions. So if you want to mention something or talk about something, I'm happy to oblige. But
no, it's 6:30 and the pubs are open, so
it has been an amazing session, and I enjoyed this. And thank you so much for sitting down for the interview with me. It's been a blast.
Yeah, it was a pleasure. Thank you very much.
So everyone listening to us, Bye-bye. I will see you next time after the next Virtual Jack session. Thank you to John. Go find him on Twitter and ask all kinds of brilliant questions.
Yeah, fire away.
Thanks a lot. Bye-bye.
Thank you.